So if we take a look at hydrogen again, our little atom has how many protons? Plus one, just one little proton. So I'm just going to draw the proton here. There it is. There's two basic rules. Two basic rules that you have to follow. And if you follow them, honestly, all of chemistry, most of basic chemistry is based on it. And here are the two rules. All right? Atoms and molecules favor a neutral charge. All right? Atoms and molecules favor neutral. Energetically speaking, they are more stable when they are neutral. I used to say they like to be neutral, they want to be neutral, but kids get all confused. So they want to be neutral. What is neutral? That means a zero charge. If I have a plus one, how do I get zero? Subtract one. I need a negative. If I have a plus one, I need one negative to get zero. So how many electrons do you think hydrogen normally has? One. One electron. That's the normal zero charge hydrogen. But there's a second rule. That's only one of the rules, right? There's two rules. It's just two simple rules. They favor atoms and molecules. Let's just say atoms. Favor a full outer shell. Now, if this is an atom, this is an outer shell. I am not going to go into, I used to have you guys as ninth grade biology students go through and fill in all the electrons and do the up arrow, down arrow, and talk about orbitals and hybrid orbitals, and kids would just balk. Their little heads exploded. After the fifth kid's head exploded, I said, okay, let's stop that. So the first two elements, hydrogen and helium, they only need two electrons in their outer shell. This is their outer shell. They only need two electrons to be full. That's all you need to know. So hydrogen just wants two electrons. So how is this hydrogen going to get two electrons in its outer shell? Let's say it comes up and meets a second hydrogen. Let's say these two hydrogens. Here's a hydrogen. It has an electron. Here's a hydrogen. It has his electron or her. These two are sitting there. How is it that these two atoms can get two electrons around them?
Connect.
They connect. They share. They share. They share these electrons. What does it mean? How many electrons does this atom have?
Two.
How many does this atom have?
Two.
Now, a lot of kids, they don't understand sharing. So they say if this guy has two, then the other one has nothing. Right? But that's not sharing. Sharing means you both have it. Does that make sense? So another way to draw this, if I were going to draw it, again, and make it simpler, because nobody wants to do all this drawing with circles and ellipses and etc., right? So what we draw is H, line, H. What is the line? What is the line? It's two what? Two dots. A connection, two dots, right?
Mm-hmm.
Two points define a line. You remember learning that? All right, on a graph anyways. So this line represents the two electrons that are connecting it. Each one of them gets two, so this is stable. Another way of drawing this would be to do this. If you see H2, what is it? Hydrogen, and it's a gas. Just so you know, hydrogen gas. You will be making this in class on Friday. Hydrogen gas. So That's hydrogen. So that seems easy enough, right? Okay. Now, this is called, by sharing, it's called covalent bonding. Covalent bonding. These two share those electrons, everybody's happy. These two atoms are both happy. What's this called? What is sharing electrons called?
Say that again.
Covalent bonding is correct. You just read it off the board though. All right, so anyways, so covalent bonding. So that's the sharing of electrons. Now, there's something else that can happen. Is you can get a little, now these two are they're the same, right? These two are about the same size. It's like any one of you ninth graders coming up and with another ninth grader, and you're going to share your money because you have no choice. If you want to buy a cake that costs you $100 and you each have 50, you're each going to pitch in 50 so you can buy the cake, right? So you can share it. But what happens is that you got your bullies, right? You got your seniors. You got the gangsters. The rice and beans, there you go. Now this can go on YouTube, don't get me beat up. It's my neighborhood, all right? And back off. All right, so chlorine's one of these, look on the right-hand side of your periodic table. Right-hand side of your periodic table. These elements, again, I used to go through this in detail. Do you see where it says at the top, the Roman numeral 7?
What?
At the top, it says Roman numeral 7. At the top of the column, you see how they have Roman numerals? Do you see where 7A specifically? All right, at the top, 7A, no, those are letters. But there's 7A, and there's 1B, 2B, 7B. But look at 7A. All of those are very close to 8. Every element, except for hydrogen and lithium, they want two electrons in their outer shell. They want I'm sorry, I reversed that. Hydrogen and helium only want 2. Everyone else wants 8. 8 electrons in their outer shell. Is that clear?
Yep.
It's not really true, but close enough. Almost every element on the periodic table wants 8 electrons in the outer shell. The top number, that number at the top, look at me carefully and listen to me. I'm not talking about these transition metals. That's these things in the middle. I'm talking about everything else. On the right-hand side, starting from boron, the B, all the way down over to the right where it says neon, Ne. Do you see that? All the elements on that side of the periodic table, all of them take electrons. All of them will share or take electrons, especially the last 6 and 7, especially 6 and 7, those two columns. And the ones we have to worry about are chlorine, oxygen, and sulfur. They love to take electrons. They're what we call highly electronegative. So chlorine is one of those bullies. It takes electrons. How many electrons does it have in the outer shell? It's the Roman numeral at the top of the column. How many does it have? 7. So I'm going to draw 7 here. How many does it need? How many does it want? It wants 8. Just needs 1 electron. That's all this thing needs, is 1 electron. Now it comes along and meets this hydrogen that has 1 electron. Now this thing is a bully. It's big. All the 6 and the 7s, they're bullies. They're going to take what they want. It's not going to share with hydrogen. It will not share. What do you think happens?
Take it.
It takes it. It's going to take that electron.
What do? Swallow it?
Watch. What's going to happen, it's a good question, is it takes that electron, it pulls it in, and just takes it, rips it off the hydrogen. Then what you get left with in the end, and I'm going to put this is called yields. It means you start with this, and you're going to end up with what you see on this side. This is something that's called yields. All right, so it yields what comes next. So when that happens, you're left with hydrogen that's missing an electron. Does it have a charge?
Positive.
It has a positive charge. Good. It has a +1 charge. The chlorine now has how many electrons?
8.
8. It had 7. It was neutral. Now it has an extra electron. What charge does it have now? That's right. Somebody said -1. So it's one negative charge. Why? Because it took the extra electron. It took this electron from hydrogen. When it took that electron from hydrogen, it became negative because it has an extra electron. It was 0, but now it has an extra electron. So it became negative. It's happy because rule number 2 is fulfilled. But it's still not perfectly happy because what about this one? It's not neutral. So they hang out with each other. We call it an ionic bond. They're associated. They're not really sharing. It takes it. But we call it an ionic bond. This happens a lot. I'm going to give you a couple more examples. Another bully called chlorine. Again, chlorine. Oh, I put carbon here. I'm sorry. That's chlorine, Cl. So chlorine then can meet up with sodium. Now on the right, how many electrons does sodium have in its outer shell? Look, where are you looking on the periodic table?
You got 11.
Look, okay, you're right. It has 11 electrons total. You're right. But how many electrons does it have in its outer shell? You have to look at the top of the column. 1, right? It has 1. Does that make sense to everybody? You're looking at the top of the column. Not the middle, not the elements in the middle. That's a little more difficult to discuss. But the ones on the right have either 1 or 2. The ones on the left have anywhere from 3, 4, 5, 6, or 7, or 8. There's 8. So this has 1, 2, 3, 4, 5, 6, 7, 8. 7. Sorry. What's going to happen? It's going to steal it. Chlorine's going to take it. And what happens is that you get what? What's going to happen? What are you going to get? Sodium what? Positive, because it's missing an electron. And chlorine what? -1. That's sodium chloride. That's salt, table salt. You eat it all the time. When you put it in water, that's why it's going to turn into ions. These are called ions. When an atom is charged, we call it an ion. So these are ions. This is an ion. That's an ion. That's an ion. Any of these atoms that have a charge, we call it an ion. It's just sodium. It's just hydrogen. It's just chlorine. But it's them with a charge. The electrons are not balanced. We call this an ionic bond. It's different from sharing. When you're sharing, they're both equally strong. Nobody's bullying anybody. They're sharing the electrons. There's no charge. Notice that there's no charge. That's why these guys end up being gases, usually. These end up, the things with ionic bonds tend to be liquids or solids. Why? Because what's this positive charge going to do to the negative charge? What does positive do to negative? They cancel each other out, so it'll be 0. But what do they do to each other? What does the positive side of a magnet do to the negative side of the magnet? They attract. They attract. So they pull towards each other. They're stuck to each other. You want extra credit? I'll give you 1/3 of a quiz score if you do this. I'm about to tell you. You go home. You get a balloon. It's a lot. It's some work. You might have to go and spend a whole $1 or something. But get a balloon. Fill it up, tie it off. Take some table salt. Ask permission from your mother first, or father, or guardian. I don't want you causing a mess, and then your mom's calling me, telling me that you made a mess in the kitchen. Put the table salt on a plate. Take your balloon and find something that's wool. A sweater, carpet. You can use your hair as long as it's not full of gel. And rub the balloon on. Rub your balloon on your head. You're collecting electrons at that point. You're making the outside of the balloon negative. Then go and move it towards the salt. Don't touch the salt. Move it near the salt. And videotape this, so I want to see it happen. So I need evidence that you did it. If you do that, I will give you half a quiz score.
At first you said a third, now you saying half, okay?
Did I say a third?
No,
I said a third.
No,
I said a third. I'll rewind it. I'll rewind the tape.
But the last time you said a half.
Yeah, so it's a half.
I like how this is. You should be a lawyer. All right, so we'll go with half a quiz score.
Y'all are what?
Yes, sir.
You have to do that. Now, here's something else you can do for fun if you want. It's not really directly related to this. So, if you take a pie pan, a tin pie pan, do the same thing with the balloon, same balloon. Move it near the pie pan and see what happens. Move it slow. You can record that too. Do it slow, and if the lights are off, you'll really see it. You'll see.
I'm dead.
Has anybody done this at all, ever?
The balloon, yeah. I did a balloon, but I ain't did that.
You'll have fun. You will have fun doing it, I think. And if you have a little brother and sister, make sure they're in the room with you. It's safe. It's safe. So again, let's review the procedure. You fill up the balloon, rub it on something that doesn't have oil on it. Rub it on it, really nice. The more you rub it, the stronger it's going to be. Put the salt on a plate. Honestly, the best thing is to put the salt on a black piece of something, and not plastic, because something else will happen. You want it on like a black piece of paper or something, or a black table, because you can see the salt clearly. If you look real close at the salt, what you're going to see is little cubes. The salt are made of little cubes. That's because what happens is the sodium gets surrounded by a chlorine, sodium, chlorine, sodium. Do you see what's going to happen? They ultimately end up making a cube because of the way they're ionically binding. They're making a matrix. So you have all these charges. You can imagine, you could go ahead and make a hypothesis and think, what do you think is going to happen when you move that balloon near that salt? Don't tell me. I don't want to know. Go ahead. You can make your guesses on videotape before you actually do it. Anybody that does all the hypotheses and everything and does a good video, if you do a good enough video for me to share with everyone else, you don't have to show your face. You don't have to be embarrassed. If you do a video good enough for me to share with everyone else, I'll give you a whole quiz score. All right? Fair? All right. Say again?
Can you send us the instructions on Twitter?
I'll post this. Is that fair? I would just send you the instructions. The issue is I have to go right after school today. I have to go to the Cleveland Clinic to go pick up a bunch of lab equipment for you, but I don't know how long it's going to take, and so I don't want to promise you I'm going to do anything like that. But at lunch, I can right after you leave, I can upload this to YouTube, and you guys can access it there.
What's the YouTube channel name?
My name.
Your name?
Yeah, Manuel Mendoza. Yeah.
Okay, man.
What's gonna happen if you use plastic?
You can go ahead and do it. See what happens.
Is it gonna be like, is my mama gonna get
plastic.
Right.
Just do it with your mama. Your mama might enjoy it. Would I tell you to do something that's dangerous?
She said maybe.
Just don't. Don't. And then if you want, you can do it later. But if you're gonna do it initially, don't. because it's good. Why are people putting things away? I still got 5 minutes, all right? Isn't this class over in 5 minutes?
10:45. 44.
When is the class over? Look, 10:54. I got 5 minutes.
4 minutes.
Now I got 4 minutes after you argue with me about having 5 minutes. All right, so that's really what it comes down to. Wait, I want to wrap this up, okay? Let's wrap it up. So there's those two concerns. You got, look at what I'm doing. I keep doing this Cornell stuff here because I expect you to be doing it on your notes. And I think somebody in the back's going to have to move up to the front because I need to see that you're actually participating. So we said there's two rules. You need to know your rules for electrons. Let's call it for bonding. There's two kinds of bonds. There's covalent and there's ionic. Is this neat enough? Is this clear enough? I didn't go too fast? All right. Ionic, and the summary here is I need to know the different kinds of atoms, ions, and not, and let's put that up here too, ions, and the different kinds of bonds. And what do we talk? What's the topic? What's the title? Chemical bonds. And of course, my name, period, date. I'm reminding you because when I grade notebooks, people are going to lose points because they don't put their headers on their papers. I'm doing it. I'm doing this because I'm trying to model it for you. And of course, I would put pages on it. I would put page 5 of 5. And I can't tell you when in college and in medical school how useful it was when your papers fall out on the floor and you have to remember what, instead of looking at a date and trying to put things together by date, you have page numbers. Wow, it's so easy. Yeah.
Is that an of or a plus?
Where?
I was thinking.
Those two things.
This thing here?
Yeah, that.
That's an and. It's just a quick way of writing and. I do shorthand. When I take notes, I do shorthand. Instead of writing the word and, I put that little symbol. Instead of putting different, I'll put diff. It saves time. You know, one of the things that somebody said yesterday to me as kind of feedback is I find it hard to keep up with the notes. I'm writing stuff and you're going on to the next thing. But that's because you're trying to write out the whole word. You're worried about spelling. You're worried about punctuation. These are notes. This isn't a paper. So you need to, as long as you can read it, you know what the meaning is, and it's clear. Instead of writing add, just put a plus sign. Yeah. They're here on the board in the notes. I'll upload them now. Yeah. The what? The summary reads, I need to know the different kinds of atoms, ions and not, and the different bond types, the different kinds of bonds.
One more class too.
No. When do I give homework? This is.
You really get homework.
I give you projects that you have to get done, but it's a lot. It's work. The main thing. Oh, on your way out, I need your contracts because I need to go through see who has them, who doesn't. Hand them to me on your way out. Thank you. Thank you.
I don't know why I have three, but they're all.
This is not signed. Whose is this? Tariq, you have to have this signed at the back. Sign it and have your parents sign it by Friday.
See about Friday.
By Friday, that's the day of the lab.
Okay.
Thank you.
Is
Thank
that how
you.
you spell ibuprofen?
Yep, that's good for me. Amoxicillin and ibuprofen? Do you take, what do you take, aspirin when you get a headache? Oh, no, you have to take Tylenol. Yeah, that's right. Acetaminophen. Well, I'm not gonna give you either one of those, so I don't have to worry about it.
Why?
Although, if we did a bacterial, if we're doing bacteria, like growing bacteria on a plate, and I'm using amoxicillin, are you allergic? You have to be careful. So you have to remind me that if you see that word amoxicillin, remind me that you're allergic. Because there is an experiment, I don't know if we'll get to it this year, but where we grow bacteria on a plate, and one plate has an antibiotic and the other plate doesn't.
Okay, I have a question.
Yeah.
Okay, so I actually learned this stuff last year.
Which stuff?
Like what we're doing now, like with the covalent ionic bond.
Oh, good. So you're ahead of the
We had
game.
to turn this
Yeah.
in today.
Hold on. That wasn't collected. That's for you to review. That's not due till September 10th. Yeah?
But I just want to make sure like what we do in this class won't be like a repeat of like what I did at my old school. Like
Oh, I don't think it will be.
you know.
Did you look at the biomolecules? What I
No.
handed out to you? You've not looked at it?
Oh yeah,
You looked at it?
yeah.
And that's all, you covered all that?
Not all of it, but like a lot of it.
Did you?
Yeah.
I don't think, we'll see.
Okay.
We'll see.
Okay.
But this is only going on till September 10th. Then we're gonna use this to move on.
Okay.
So,
Thank
this is
you.
what we're talking about now, what you covered in middle school, we'll be done with at the end of the
Well,
week.
yeah, I'm sophomore. So.
Oh, I see.
Yeah.
I'm sorry,
okay.
I'm used to ninth graders. When you're done, what you covered last in chemistry is gonna do you very well in this class.
Okay.
So you'll be using it. So use this as a time to review.
Okay.
And when we move on and start to talk about how these things interact, polar, nonpolar, what crosses the cell membrane, what doesn't cross the cell membrane, how fast does it cross, how do you make ATP, what's photosynthesis, what's cellular respiration, you're gonna be ahead of the game when we get there. But it will not, I believe it will be neo, unless, I can't imagine you cover that in chemistry.
Yeah.
All right, very good.
Are we gonna learn how to combine elements?
We're doing it tomorrow, on Friday.
Alright, I went there in 7th grade.
Yeah,
Do we have to use a front and the back one, or can I just staple these?
you can staple them ahead.
Is this what you was talking about today? Because
That's Cornell's, yeah, it's it.
Because I'm talking about like the thing. Cause I like watched your video like Sunday.
Oh, that's nice, very good.
Was that what you was talking about?
Your electrons moving, that's what I was talking about when we talked about iron and oxygen, yeah. Those electrons moving around. That's good that you made that connection. That's exactly right.
Okay.
All right, kiddo, have a good one.